So today I'm going to talk about graph theory for multi-agent integration. Imagine having different, diverse, and specialized models working together. For example, you can have speech integrating with LLM model and with an audio model. Maybe you could have a recommendation model that's work with all of them together. This might be a complex task to integrate all these diverse and specialized models. One way to do it is the graph. The good thing about the graph is provide foundation to integrate multiple nodes, and you can look to these nodes as agents, and each agent is specialized in one thing. Another thing, it's help you to manage the dependencies. So no need for manually to say which model should start and which model should go next. Everything come out of the box from the graph. And finally is the parallel execution. You want your application to work fast. So because the graph shows the relations, which model are related to each other or which steps are related to each other, automatically the graph can help you to run the things that's independent into parallel steps. And we're gonna see all of this working together. I'm gonna talk about clinical use cases from my experience with hospitals. I will not talk a lot about the introduction because Alex made a really good one, but mainly I co-founded a medical company and we apply these techniques in real scenarios. Yesterday, for example, I had a meeting with a clinician who work in one of the London hospitals, and I tried to validate some of the ideas. I'm gonna talk about it here. Let's consider this case. A 65-year-old patient come to the hospital, and a clinician do an assessment for them with the help of AI. And the AI did the assessment that the patient has low risk of heart attack. However, let's assume this wrong prediction that might impact the patient's life. Hopefully in this scenario, they caught this false prediction early and they helped the patient on time. But in other situations, that might impact people's life. This is one scenario from the clinical use cases, but in other industry, you might have other critical situations where you want to understand if there is something wrong happened. When you apply those AI models, you don't want to treat them as a black box. Transparency is very important, and this is one of the main use cases for the multi-agents and the things I'm going to talk about it today. We published a paper called Enhancing Clinical Decision Making using multi-agents. And why this is helpful? Because as you see in this graph, the multi-agent approach, it's help you to divide the steps so you understand if something happened wrong. For example, in the use case we talked about, maybe the lab results included some anomalies that impacted the prediction of the model to be wrong. If we treated all these data together through one model, yeah, it might be simple, but it's gonna look like a black box. It's gonna be hard to trace which step caused this situation. So here, it's just suggestion to break down the steps. Each agent analyze different thing. Then you're gonna have an integration step that integrate all the results together because the prediction should look into everything. However, each agent gonna write their contribution or share their contribution with the user in order to know why they said this kind of prediction. So from the vital signs perspective, for example, this is the key factors that impacted this kind of behavior. From the lab results, this is the key factors that impacted this kind of prediction. Then when you have an integration agent that's look to everything together, also it's gonna add its output here into, for example, your logs. This way you can trace really what's happened step by step, and you're gonna have more transparency. In this paper also we introduced things like transparency agents in order to analyze those nodes, in addition to validation agents in order to verify everything works as expected. So this is one suggestion of best practices. You can apply it when you work with multi-agent systems. Another thing we evaluated, there are other papers published that's about the multi-agent system, and one of them called Why the Multi-Agent LLM System Fails. It's from UC Berkeley. And the researchers found in many cases simple models work better than multi-agents. So okay, like multi-agents is important, but it might fail in some cases. So how to fix this issue, for example, one thing we verified, we did the same analysis and we found similar results, but we applied something called a shared memory between all agents. So once the prediction step see the data from here, it might miss some context, but because there is shared memory across all the agents together, the prediction step agent or step, if it's found something is missing, it can refer to this missing data from the beginning. And when we apply this shared memory technique to the multi-agent system, we found it enhanced the accuracy even better than the single agent in this case. So yes, you have to apply multi-agents to have a little bit more of traceability and transparency, but sometimes simple approaches work better, so you have to know when to use multi-agents and when to use the single agent thing. Even if you use the multi-agents, you have to apply technique like the shared memory in order to have a better integration between every agent. And we're gonna do a lab at the end to see how everything works together. Just I made a checklist in order to help you to decide when to use multi-agents. But at the beginning, I have a question, like how many person here try to build just a simple LLM integrating OpenAI, Anthropic, or open source thing, just a one step, like one agent? Did you try to do this before? Okay, great. And this is, I see lots of hands here, and this applies to the most use cases. Did you try to apply multi-agent approach, like having multiple steps working together, each integrated with the front model? Okay, cool. There are also few hands, less than the single approach, because single approach is suitable for many cases. So if you want to decide when to use multi-agent, one reason if you want to integrate multiple specialized models, for example, you want to integrate speech step with language step, let's assume vision step, all of these together, why to write the code and orchestrating them yourself? Use a framework like the graph is gonna help you with the orchestration. Another thing, if you want, another reason, if you want to break it to multiple steps, for example, the clinical situation we've seen, it's included multiple evaluation steps. This is another reason you can apply it in any industry, not only the healthcare. If you want to isolate errors, so if one agent fails, you know which one failed and or which one included missing data, so you can fix it in isolation. And finally, the other reason is modularity. So you can replace one model with another without impacting everything. If you have one step that's read images using a vision capability, why to touch the code of everything? Just replace that vision step. And that leads us to a graph to orchestrate the agents, which is the suggested approach. You can do it in many ways, but the graph, as we discussed, is going to help you to manage the relation easier without writing lots of code. So you can treat the nodes as unit of work, or you can call it a task to describe what the agent should do. So each one of this you can look at as a task, and you can assign to this task an agent. So you assign to one task an image agent, another one a vision agent. So each one gonna have different capabilities. Then you look to the edges as the way to how to transfer the data from one step to another. So you can build a complex use case. You can apply static edges, like here for deterministic approach, or you can have a prediction step in the middle, where you have a model that decide which step to follow next. Also, you can utilize existing techniques in the graphs. For example, in the graph, long time ago, even with maps, we have depth first, we have breadth first, different navigation techniques. No need to invent the wheel. You can use these techniques to navigate the nodes when you build a multi-agent system. This available through a library called IntelliNode. I'm one of the main contributors for this library. It's published in 2023. It's Apache 2.0 open source. You can use it to build those graphs. It's mainly focused on this use case to build these kind of complex graph. And there is sequence flow and async flow. The difference is sequence flow if you have a simple use case, async flow if you want to run multiple things and you want to have parallel within your implementation. It's implemented as in a modular architecture. You're going to have one thing is the model or the tool that you want to have it at each step. You assign this model or tool to an agent. Then this agent, you assign it to a task. Previously, it used to be a tool. Recently, we started to hear more about MCP. So I added the MCP to this library. So instead of a tool, one step can be an MCP agent. And this is going to be one of our labs. You can download the library using this pip install. By the way, in the Slack channel, I shared the lab link. It's available at the end, but if somebody wants to access the lab earlier, you can find it in the Slack channel. This is an article from Yann LeCun. He's a French researcher, well known. I don't know if you know him. Maybe if I edit his photo, everybody will raise their hand. He worked as a head of AI in Meta, and he worked as a professor in one of the universities. The thing is, he published an article in 2022 describing the intelligent system and how intelligent system works. He didn't talk about the graph directly, but when I looked to this article, I found he's talking about something called configurator, and this configurator helps to orchestrate things. Then one step is the perception, which process raw data, and that's look like an agent. Then we have an actor that's process the task. So that's inspired me to have this graph relations that's available in this article and come up with the idea of having tasks with agents and so on working together. This is an example just to give you a high-level idea how to build something like this before we jump to the hands-on labs. This is one example about generating a GP letter based on speech data and X-ray. The reason I'm showing this example because it's going to require multimodal capabilities. It's something relevant to the things we're applying in healthcare, but as a disclaimer, this is just simple for learning purposes. When you apply to healthcare, you have to apply more of governance around it, traceability, ability to reduce the errors, and so on. So this is only for simple purposes, for the learning purposes, sorry. So one step is the agent. Here we're going to have a speech agent that's going to analyze the notes from the doctor, recorded from the doctors. And we're going to have a vision agent, and this vision agent will analyze X-rays. Then it's going to use it to generate at the end a letter which requires language model to write the letter to the GP describing what's happened with this patient. By the way, the doctor spent lots of time doing this kind of administrative stuff. And like one of the things we're trying to do to reduce this time on them. And this really helping the doctor because they don't like this kind of task. They prefer to focus on patients. So this is one of the use cases that can benefit the health industries. In between, you can apply a processor. So in the graph, it's going to work out of the box. So no need to write a custom code to say how to transfer speech to LLM or vision to LLM. But if you want to have a validation step in the middle, you can write pre-processors and post-processors using this example. And again, this example is based on async flow, so you can run things in parallel. So from here, we can run these two steps in parallel, but this cannot run except when these two steps finish. So the graph is going to help us to orchestrate all of this together. And here is a high-level code example. So in this example, we have a speech agent. The mouse is visible. Yeah, cool. So we have speech agent. For example, in the speech step, we want to use a Google model. It could be open source model, something you load it offline. Also, this is supported. So the idea is you don't have to stick with one provider. You can cherry pick the best model in the market. So you say the provider for this agent is Google, and we want to use WaveNet speech model. In the vision step, you could use, for example, OpenAI or any alternative in the markets, and you have to mention what's the model name. And finally, the LLM step, in this example, I use Anthropic. Again, like this is just to show you can integrate multiple providers, but it depends on your use case. For example, I saw OpenAI O3 good with reasoning, Cloud good with coding. So if you have something that includes reasoning and coding, why to stick with one provider? You can use the best from each company. But this is only preferences, like based on your use cases and testing. Then you have to design your task, and in the task, you have to describe the agent what they have to do. For example, here, you can write the prompt to let the agent know they have to generate a GP letter. In this step, you can let the image model know which X-ray image to use, and again, the speech model, you can give it an audio file. And this is how you build your graph at the end using something called flow. So you give each task a name. So this is the task. We built the agents at the beginning. We assign the agent to a task. For example, the vision agent assigned to this task. Then we start to orchestrate things. So we tell the notes step, gonna go to the GP letter. The X-ray step gonna go to the GP letter. Then the GP letter is the final step, doesn't go anywhere. Then it's gonna help you to generate a graph like this. This is high-level idea how you can build the flows. We're gonna jump now to the lab. So if everybody can scan this QR code, it's gonna open for you a GitHub repository, which include 3 labs that we're gonna run through them together to get a practical experience. And another thing, this is gonna be temporary. I'm gonna delete it before the live video. So this is a temporary API key for Anthropic and OpenAI, just to make this lab easier for you. So one QR code for you to open the keys and the other one to open the labs. Just, I will give you a few seconds to scan them. Okay. I opened the GitHub. If anybody didn't scan it, let me know. I can back to the QR codes. Are you good? Great. So this is the lab. You can install the library using pip install Intelli, but if you want to run lab 3, which include an MCP step, you have to write pip install Intelli with MCP. This is gonna download for you the MCP library from SDK from Anthropic. It's open not for Anthropic models only, but they are the provider of the MCP. They published the first MCP idea. And by the way, like MCP is just the tools. If you use those models before, you used to define tools, but MCP just a fancy name to make these tools available through HTTP, so they're available through remote. It's like any API, but a little bit fancier. It's include a little bit of description for the model to know each API objective. To run the lab locally, I'm gonna run it myself if you don't want to run it, but if you want to have a hands-on, just you have to create .environment file locally and set the OpenAI key and Anthropic key. You can use your own key, or you can use the keys I provided in the QR code. The lab's gonna be 3. The first lab, just a simple way to show you how to integrate, for example, OpenAI model with Anthropic model. It's gonna talk about building a nutrition assistant. However, the same concept can apply anywhere. The second lab, it's about generating content, for example, for your website. And the reason for this lab to show you how to integrate text with image and speech capabilities. So you will integrate multiple model types. And then we're gonna have the lab 3, which is MCP. And inside this lab, I will show you how to run MCP server. For this MCP server, we're gonna use Polars. Polars is a new library. It's like Pandas, but much, much faster. So you can have this Polars as your MCP server, providing data for your AI models. And then we're gonna have MCP client and a step to analyze the data and do prediction. Okay, let's start with lab 1. In lab 1, as we said, we're gonna build 2 agents. Agent 1 gonna analyze notes, clinical notes. In this situation, is gonna be fictional notes from one client that visit nutrition clinic, client or patient, whatever you wanna call him or call her. Then in agent 2, we're going to have an agent that use LLM model, mainly anthropic in this case, in order to provide a plan, meal plan for that patient. So if you created the .environment file, you can run the steps one by one. The first one is gonna install for you the required libraries, which is IntelliNode, and the other one is .environment in order to load the keys automatically to the notebook. And if you created the .environment file correctly, you should have OpenAI key available, Anthropic key available. This way you know you can run the notebook. This is just a fictional note about a use case about some client who visited a clinic, and the clinician wrote this kind of note describing the use case in order to use it in our multi-agent system. And here we're gonna have two steps. One step gonna be an agent that analyzes the notes, extract relevant information. So the next agent gonna do less errors because it's gonna focus only on the relevant information, and the next agent gonna create a meal plan based on this personal information. And again, you can be creative in the way you write the mission for the agents. Also, later you're gonna write more description in the task step, because this agent step only focus on the idea like what's the provider, what's the model you want to use it, and a simple mission to describe what this agent has to do. Then in the task step, you can write more detailed prompt, for example, in this case, what kind of items we want to extract from the case note. So here we have the note about the patient or the client who visited us, and we tell the agent only extract this information which is relevant to the meal plan. And the second agent, we tell the second agent create a simple 3-day plan for weight loss. Again, like these models doesn't know your objective. So one of the most important thing when you create an agent or you work with a model, to really describe what's your objective. Like if we didn't tell the model we want a meal plan for weight loss, there are other reasons. They can build a plan for muscles. So this is one of the things always we tell the doctor. When you write your notes, please write everything you want to deliver to those models, because they're not gonna know the things in your head. And then we assign the agents here. So here we assign the first agent, and here we assign the second agent to the second task. And you can create the flow. The flow is from the assessment task to the planning task. It's only 2 steps graph. I generated this graph. You can generate this graph to help you to visualize how your flow or graph look like. And this is the one at the top here. So if you're running this locally, you're gonna see the graph generated in the output folder. And now let's run the flow. It's only 2 steps, so I didn't use workers here, like there's no parallel, but this library allows you to define number of workers, how many steps you want to write in parallel. And here you're gonna see the agent is running, so executing the task 1 using OpenAI. It's gonna tell you what's the output of this step, then it's gonna execute the next step, it's gonna tell you the output of that step, and at the end you can extract the output of each step separately in order just to make sure into the validation everything works as expected. So here we have the output from the second step for the meal. So this is 3 days meal plan. You can be creative, make it 7 days. You can write different reasons for your meal plan, and the Anthropic agent can help you to write this plan. In the analysis step, also you can manipulate the prompts. You can write other things to extract from the notes. Here we used OpenAI, for example, and OpenAI extracted which part of relevant notes to use in the next step. So this is the simplest approach to build 2 agents, both of them LLM, just to help you with the introduction. But then we can build more complex stuff using Lab 2. I will give you like a few seconds if anybody's still running lab 1. Any questions on lab 1 so far? So in lab 2, we are talking about a little bit more complex case comparing to the previous one. We want to integrate an image model here. Here is the image model in order to generate a banner for our blog. And we want to create a speech model, and this model can generate an audio. If somebody asks your blog, they don't want to read the text, they want to listen to that, maybe while they are in the gym. We can generate an audio. Then we have 2 LLM models, one that's gonna write the blog itself, another one that's gonna write the image description. And this one of the smart ways you can deal with image models, because sometimes image model, if you feed them lots of data, irrelevant data, they're gonna generate something that's random. But if you have a step in the middle and you describe how the image look like, it's gonna make the image model work much better. The alternative to this, there are some models in the market that include multiple capabilities. Like some companies that release models that include vision, image, and text capability. But usually those models doesn't master everything. Those models might be better with images, but not good with text, might be good with text, not good with images. So the idea here, to cherry pick the best in the market. You can, if the best model in the market currently to create images come from OpenAI, tomorrow might be from Google, you can easily switch the provider for your step. Again, if you don't work with this company, there is no reason for you to stick with their models. You can always switch between them after doing your own evaluation. So again, the first step is common between all labs. It's only about installing the library, loading the keys. Here, for this example, I have Gemini key. By the way, like I tried to run this lab in Ireland, Gemini not available anything under the European Union, so usually I open VPN. I think it's open here from London, but if it's not, if it doesn't open, I will go to the VPN. Usually I use VPN from US, but I think Gemini available here. So this is the description of the blog. Again, I used a blog about just a topic for PyData. Just having, for example, let's assume PyData, they want to target specific audience, what the audience they want to target, and to talk about this session, for example, or any kind of event session or the event overall. However, you can tune this based on your use case. Feel free to change the blog topic. And here, you're gonna find agents 1 that's gonna write the blog. It's in this example, I use Anthropic with Cloud 4 version. Then the second agent related to the image description. And the agent for image description, again, I used OpenAI just for testing purposes. Maybe for image description, no need to pay for really sophisticated model. For image description, you can use a low, cheaper model. And this is one of the use cases when you apply multi-agents. You can decide which step you will use the higher model and which step to use the cheaper model for simple tasks. And here, the OpenAI. Yeah, I think I changed this lab to use OpenAI for simplicity because Gemini wasn't open everywhere, but it's gonna be easy task. If you want, you can go to the docs and you can find docs.intellinode.ai if you want to change one of the steps to use Gemini. And this is the tasks. So task 1, we describe what's our objective from this blog, how the blog structure should look like. Again, if you tell the model, write for me the blog, they might write it in 100 different ways, but each company, they have their own standard. not because the standard is better, but just for unification purposes. So we tell the blog how many paragraphs we expect, how many words, how the blog look like. The more you write into your prompt, the more the model aligned with your internal, for example, company or internal use case, if you are just a developer who use these applications. And here we describe the image. One good reason here for having an image description task, we can tell the model what's the style of image. This you might generate this image in a specific style. Again, the model can decide to generate it in any random style, but good to break the steps and describe how the image should look like. And finally, we have the header, the step that generates a header. We tell here only the model generate an image based on the description. And because we assign the image creator is the agent that use the image model, it's gonna generate the step for you. The good thing here, no need to define how to move the data from one task to another or from one agent to another, because the task got keyword autosave output. Sorry. Just make sure if you want the optional parameter, you have to download latest IntelliJ library. It seems here I don't have the latest. So I just removed the optional parameters. But if you want to write it locally, just make sure pip IntelliJ U to upgrade. And this way you're going to ensure you have the latest one, which is 1.1.6. And the idea 1.1.6 will allow you to save automatically the output. Because the output that comes from each step, you have to save it yourself for traceability to know what's happened. But there's a parameter called autosave where it's automatically save everything from each step. Okay, I'm not sure why it's not loading it, but I'm gonna hide these parameters for now. This step gonna generate the image. You're gonna find the image of the graph, this one, in the output folder. And finally, you can write your flow. Flow.start, you give it the max workers. So here we can run 3 tasks in parallel at any time based on the dependencies. And now the model gonna go through task by task. Automatically, it's gonna know how to transfer the data from text to image, text to speech. Even if we have speech to text, automatically things come out of the box. And for transparency, we print the logs of everything. Yeah, it's gonna keep working in the background, and it's gonna export the outputs for you. And here you can trace what's happening at each step. Everything is completed, successful, and there is an image generated out of this lab. Okay, so that's lab 2. I will give you just a few seconds if anybody running lab 2 before we jump to lab 3. Lab 3, I will let you run a few steps together, especially for the agents. In lab 3, we're going to talk about MCPs. I think the pullers as a server can apply to lots of use cases. It's going to help you with your work. I will give you just an example before I go to the lab, just to give you a chance to finish, why we might need an MCP server that load CSV files. From my use case, when I work with the healthcare industry, not all the hospitals or not all the doctors using the latest systems. There are lots of things that still in CSV files, in documents, and so on. And it's really hard to integrate because these kind of data are not available through API. So how we can provide this data to our models easily? One way, you can build an API again, but after you build the API, you have to write description how to use the API, or you could apply the MCP concept. The MCP is Again, just an API with a few fixed parameters in order for the model to know which API to use. So in this example, let's assume there is CSV in your organization and you want to provide the data from the CSV to your LLM. You can run a server using Pullars, which is gonna load this data. Again, Pullars is multi-threads. It's able to handle large data. It's safe to work with it using as a server, I mean, comparing to other libraries. Then once you have that MCP server, you can connect the URL to your agent, and your agent will be able to use this data in your use case. This is just a fictional use case about prediction, most relevant to the one in the article. So the first step, we're gonna run the MCP server together. Then we're gonna have a context agent that's gonna analyze everything from those CSV files. For simplicity, I didn't break the steps to 3 agents, so it's gonna one agent read every information for the patient, including vital signs, the doctor notes, lab results, everything gonna be loaded to one agent. This agent gonna do the analysis and will provide their analysis to the prediction agent. And in this use case, the prediction about whether the patient, they use the word expired into this data set, but the idea of expired inside an ECU, whether the patient lived or died. So here I have sample of 10 patients. 5 of them went to the ICU and expired based on the data, and 5 of them lived after being in the ICU, and this agent gonna try to do a prediction. In the end, we're gonna compare each prediction with the real data in order to see whether the agent did right prediction or not. And I will give you an idea how the MCP server look like. So as part of IntelliNode, if you call intelli.mcp, you will find something called Polar MCP Server Builder. Again, it's just a utility that helps you easily to convert any CSV file to server, and Polars should be downloaded. So pip install Polars should be there. And this is Polars available just to check whether you have Polars downloaded or not at the beginning. This is just a function that's load all the CSV files. We have the patient CSV, we have the lab results, and we have the vital signs. This is what we got into this example. All this data came from a website called Visionet. You can download it from there. I have the source mentioned here. But for this example, because this data is licensed, I used only 10 patients. You have to go to the website. It's free. Just you have to add your information if you want to download all the data. All the data include more than 100,000 patients. You can build lots of use cases on top of them. So this step just gonna load everything, merge all this data to one CSV file for simplicity of this lab. So we're gonna have one agent that analyze everything. So if you go to the main, just this one check if you have Polars. If you have Polars, it's gonna load all the data and generate this common CSV file for you. It's gonna print the columns just for you to know what columns you're gonna deal with. And then you have to set up the MCP server. And it's really, really simple here. Only you have to call the Polars MCP server builder, which is a utility. You give it a name and you give it your data, which is this file location in this lab. And once you give it this information, automatically it's gonna make your CSV file available as a server, but Polars work with Parquet files. So if you have Parquet files, also you can provide that as a server. I'm gonna run it myself, but I just want you to do it. So if you can go to the folder, this one folder that's called MCP server. After you downloaded everything, which is available here in the README, pip install IntelliMCP, go to this folder and write Python complete patient data pullers .py. So if you write it this way, it's going to load for you the MCP server. It's a local link because we defined in our code as a local link. The host is a local link, but you can make it any HTTPS domain. Also, we defined what is the port, which is 8001, and you can change it to any port you want. Again, this code come out of the lab. All you have to do is run Python and the file name. Then you're gonna have the lab. You're gonna have the server available for you. If you do this step, it's gonna help you a lot because you can replace this CSV file with anything from your organization, and you can build endless use cases. And please run everything at least until to test MCP server. I will give you a few minutes to do that, just to make sure the MCP server is working. Then I'm gonna follow on the steps from my side. Yeah. Yeah, the part to start MCP server. To start the MCP server, the best place to go is, first of all, go to the GitHub. And once you go to GitHub, you're gonna find the steps to download pip install IntelliMCP, just to make sure MCP available for you. And if you scroll down, you're gonna find something called MCP server. It tells you, go to this folder. And once you go to this folder, only run this command, Python MCP server pullers. It's gonna load your CSV files and make it available for any language model or any tool, really. For example, Cursor is using MCP, so it can be available for your Cursor. Did anyone manage to reach this step and run the server? Yeah. Yeah. Once you download the GitHub repository, you're gonna find this folder called MCP_server. The lab's available in the root directory, but the server itself available inside this folder. And you're gonna have two servers. One of them, this one is just pandas, and the other one is pullers. So even if you run the pandas, if it's easier for you, run the pandas, and it's gonna work. Did anybody reach this step? Okay, great. Sorry? Okay, let me come. I will see the errors. The error from the testing step or from running the server?
The server runs.
The server runs, yeah. Cool.
I think we're a bit ahead.
Can you scroll down? Error. It's related to some converting integer to strings. It might be related to the way the common CSV generated, because we have 3 CSVs combined into one. For some reason, maybe because the library version. But I can follow up with you after the talk to see like how to fix it. Yeah, if you have the error, try to run the pandas, not the pullers.
Okay, yeah.
The other file. You okay? Please switch to pullers then. Yeah, good. Yeah. Okay, I'm gonna continue with the lab since one is finished. That's indication that it's working. So pip install Intelli with MCP. That's gonna download the requirements for you. Okay, polars not defined. Let me install polars. Ah, yeah, sorry. Got it. Install. So it's gonna download it for us. And this step now passed because I downloaded the required library. This is the local host because we defined the server to work as local host, but if you had a domain as we described, it's gonna work with you. And once you reach the testing step, if the MCP server is working, it should tell you MCP server connected successfully. So this is just a testing step. Now we're gonna create the agents. Here we have 3 or 4 IDs for patients, just for testing to do our prediction. And I'm gonna try to do prediction only for the first agent, for the first patient, sorry. In real situation, if you want to do the prediction, let me go here. These are the available columns that export through the MCP server. In a real situation, if you want to do prediction, it's better either to use a few-shot learner, and the idea of few-shot learner is loading example how the prediction look like. So you might have in 10 patients 2 provided as example, or sometimes it's better to do fine-tuning. However, for the sake of the lab, I asked the model to do prediction only from the raw data. The model didn't see how the prediction looked like before. It might work, it might not work. Let's see how good is this model. However, also it's the responsibility of the developer when you work on similar situation. Don't rely only on the LLM, provide the right context. Let the model know how the data look like, how previous patients' assessment worked in order to be able to do a right prediction. So here we have only 2 agents. One is the MCP client. This is the MCP server, and this is the client. And inside the client, we provided just common parameters, which is the URL and, for example, the input. The input is patient number 0. Feel free to manipulate it. You can pass different agents at different runs. And I'm going to define my task. The first task only load the patient information. The second task include context. Again, for you to do parsing, although we didn't apply few-shot learning and we didn't have fine-tuning, but at least I told the model how to do the prediction. If you want to do parsing at the end, it's important to tell the model how the data should look like, because the model might export the data in many random ways. So it's good to stick in one format. And here I told it, provide only valid JSON. Don't add any data before or after, like explaining what you did. Just export the patient, the JSON as is. However, we said transparency is important. So I told the model, write the key factors here. So don't write anything outside the JSON file. Just write the key factors. What are the reasons you did these predictions? And the prediction expired or survived. Again, these terms used in the data set itself, and to export the patient ID in order to do a validation at the end. We pass this to the, okay, I have to run this cell, and we pass this to the prediction agent. And here we define the flow. It's only 2 steps: load patient task, going to a prediction mortality task. This is the output generated. If you go to the output folder, you will find this image. This is the MCP client, and this is the LLM step to do prediction. And let's see how good is the prediction now. So the model did the prediction, and the model says this patient should survive. And the reason for this, the key factors, as part of transparency, the agents say there is stable vital signs, the lab results normal. Again, those models seen lots of data from the internet. I didn't provide examples, but they seen lots of data. Anyway, it's better to provide examples even if it's seen data online. Yeah, here I think this is related to my custom code to extract the JSON file in the validation step. I mean, like, I'm going to review this. It's not related from the LLM, I think only from the parsing. However, this didn't impact the overall prediction. Sorry. This is the code I have to extract the actual data. I couldn't extract the actual data in the validation step. It's a custom code. So let me go and do it manually for now. So the model said the patient should survive. So nothing impacted the model itself, but I couldn't load the CSV file. MCP server. Let's see whether this patient survived. I'm gonna go to the patient ID. Okay, this patient. There's 2 rows for this patient. Maybe because I ran it twice. This is why I didn't load it. I can delete one of the rows. No worries. Yeah, I didn't save. So expired is false. Expired is false. That means the patient survived. So the prediction here is correct. However, I'm going to try another patient that's not duplicated. So let's go to patient 1. First prediction is correct. Okay, again, it didn't load the original data. I will fix the lab later for this steps. So this patient, based on the model, it survived. Let's see originally whether it survived or not. Oh, again, this one, because I have run the server multiple times. So it says this patient expired true. That means the patient didn't survive. So as we've seen, the model managed to do one right prediction, and the other prediction wasn't right. The key factor for this prediction, let's see the key factors here. Error in value conversion, check data integrity. Okay, the prediction is wrong because it's the agent says in this step it couldn't it couldn't parse all the data that's come from the server. But in the 0 patient, it managed to parse all the data. This is why it did the right prediction. So here it said it's stable signs and so on. I'm just gonna delete these files and run it again. just not to have duplicate data. So this is the yeah. There is the mic. Yeah.
Hey,
Yeah. Go.
aside from this bug, if we step away from this specific bug,
Yeah.
this is like a two-node graph, and it's super fragile in a way that wouldn't have been if one would have applied basic, I don't know, coding, like basic if statements.
Yeah. 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 Good question.
I'm just like,
Yeah.
why? I mean, no, why would we go down this route? This is
Yeah.
a stupid question, but it's like this is the
It's a
hottest
good
thing
question.
right now.
Yeah.
This is the hottest thing right now, and we're looking at a healthcare example,
Yeah.
and this is like not your fault.
Yeah. Yeah. Yeah.
But you know, this is like how it can go wrong in so many ways. Why not just if statements?
Yeah, yeah. This is a good question. Again, as I said before, simple approaches might work better. By the way, the bug is fixed. I just ran the server again, but it's good this bug happened because it started this question, which is really important. MCP, again, as MCP concept, it's just a fancy term. It's not for any situation. As you said, sometimes why not to load the pandas frame itself, especially if you are working locally. But there are some reasons you might to work with MCPs. It doesn't apply to any use case. One of the use cases is if you have a ready tool, for example, Cursor. If you want to integrate with Cursor, Cursor out of the box come with MCP tool. That's allow you to load the data as MCP. So if you want to integrate with the existing system, building MCP become like a common pattern between softwares that provide this capability out of the box. Because Cursor might not include a parser for pandas or parser for or CSV files. So this way you build everything separately as a modular MCP server and provide this as a link to Cursor. And because the MCP server force a description, your agent, the client agent, gonna know how to deal with it. So only in this kind of situation. In the regular situation, if you are working on a use case related only for your application, you don't have to expose the data to many applications, the MCP might be a wrong approach. Or not wrong approach, like over-engineering. However, if you want to integrate your data for many existing systems, again, not every system now integrate with MCP yet, but in the future, you might find SAP include something for MCP. You might find Salesforce include something for MCP. It's more about having one standard, every client using the same standard. This is the only reason. Is it clear, the answer? Or?
The answer is clear. I just don't think it was the answer to the question I asked.
Yeah.
You tried to perform a prediction task.
Yes.
But the way that it was structured with agents, MCP or non-MCP.
Okay, as agents.
Fragile.
Okay.
And opaque. And a lot of this fragility and opacity could have been prevented with just a little bit more of really standard code.
Yeah.
The question is about agentic approach in general.
Agentic approach itself. Okay, I got your question. Let me go here. For our use case and the way we treat the data, for example, currently we had a bug into the data loading layer, right? When we had this bug, at least we managed to isolate everything happened into this step, not into the prediction step. So you don't have to edit the LLM part that's work with the prediction step. You can edit only the part that's work with the load data step. So this kind of situation help you to isolate the error based on each step separately. Then when we went to the CSV file, we understand what's the issue. However, if everything works from one agent, it's gonna be really hard to know which step caused the issue. I might try to dig into OpenAI, or I might try to dig into the LLM prompt, but because it's multi-agents, I managed to know only this step caused the error. I went to the ZSV file, I found there are duplicate records, I deleted the file, then I managed to fix it. Again, this is one approach. In many cases, simple model might work with you better. So multi-agents, not for every use case, only for the situation where you want to apply this checklist. So if the situation outside of this checklist, I agree with you. You can go with if statements or just one model that's do everything together. Any other question?
How do you ensure that? I come from like distributed systems, microservices background, and we have huge problems ensuring that protocols formats are the same, are consistent across your network. How can you possibly have that with LLM outputs? We all know that we can try to prescribe an LLM output format as you have here.
By the way, like you mentioned, a really good example about the microservices. So always like we had the debate whether to go with microservice or monolithic application. And in many cases, monolithic application work better. Why to go with microservices? Because the integration might have many problems. But then we started to have orchestration modules or libraries in order to work much better. So in order to have the multi-agent system work as robust as required, you have to use multiple libraries that provide things out of the box. They might exist today or might not because MCP concept or multi-agent concept is new. So the same approach in microservice, you have to apply it here. The same kind of problems you faced over there in relation to integration stuff and the errors in the middle is going to exist here. For the same reasons you don't want to go to microservice are the same reasons and the same situation you don't want to go with multi-agents. But monolithic, not the use case for everything. Again, one single step or one single LLM, not the use case for everything.
Sure thing. I love microservices. I think there's a lot of value in breaking down.
I agree. Yeah.
I think there's a lot of value, and what you were saying about trying to isolate
your
works, I think it's brilliant. What is more worrying is the fact that these aren't kind of traditional services, are they? They are LLMs. They are very stochastic by their nature, which
I agree with
is
you.
not something that's
It's more challenging. Maybe just we have to wait for the market to mature. The same thing happened with microservices. Currently, we have lots of framework to orchestrate stuff. So either you come with your own framework to orchestrate stuff and solve lots of problems. And this is a good thing because you have the experience and you face these issues. This is a new market. So you have the chance to contribute. If you want to contribute to microservices now, the market is mature, but you have more chance to contribute here. Okay, any other questions? Great, so that's all about it. Again, the lab link gonna be available. Feel free even to contribute to the lab. If you run the server twice, this lab double the records. So I'm gonna fix this issue after the talk. Otherwise, feel free to contribute this fix yourself. Thank you.